Roy, thank you very much for this interview. And it's part of a series that I'm doing with uh, a fair number of people across the globe on what some call knowledge brokering. That is the bridging, uh, being the bridge between the researcher, the education researcher, the scientist, and implementing in the classroom. And so whether you call it brokering or bridging, you've been advancing for many, many years the concept of learning engineering. In your mind, is there a concept of knowledge brokering? How would you define it?
I think there really is, and part of it is by inspiration from many other fields over the last century or more that have kind of made a transition from guild-like or instinct-like or myth-based decision-making about how to help ourselves live better lives and keep going, to more evidence-grounded ways of doing it. And in many cases, part of where the evidence is coming from is indeed some form of narrower, deeper, scientific or other kind of exploration. So, medicine is the, one of the best examples of this, where, it used to be, it was very myth-based, very much about beliefs, very much about what was in the garden of the herbalist that you went to. And, there were stories about what worked and didn't work, sometimes enshrined in the culture, sometimes just based on that person's own hands and their own claim or belief about their efficacy. And now over the last century, really, we've had a complete revolution in human health worldwide that has been driven not only by biological science beginning to understand more about how normal bodies work and how pathogens and bugs bother us and how we wear out and all that kind of thing, but actually also because of the translational research work, the actual work to try to take those narrow petri dish results from laboratories and figure out, I got a sick person in a hospital in deepest Asia or in deepest New Jersey. How do I gain benefit from that science about what could be going wrong and things that might, show in the laboratory? How do I do this practically at scale? And so that whole development of translational medicine, I think, is like that. And the reason I use the term engineering is because when you look at things like chemical engineering, electrical engineering, materials engineering, and so forth, all of those have that similar characteristic of starting from a science like chemical engineering, kind of absolutely, if you're trying to build a major new pharmaceutical factory, first of all, you don't want chemists building it because they don't care about economics. They're not that interested in safety regulations. They don't want to figure out how to make a tank that will hold 1 million gallons of hydrofluoric acid. That's not what chemists are interested in. They want to work in laboratories on cool new compounds and new understandings that are fundamental. So that's why you actually have chemical engineering schools and a profession. And the last time I looked a few years ago, there were 30,000 working chemical engineers in America who not only use modern chemistry, right? Because you do not want your chemical engineer using phlogiston theory to design your factory, right? You don't want that, right? You want them using modern chemistry, but then they also draw in other disciplines, whether it's material science and economics and regulatory work, to create an actual real world solution on a site that is practical, and then they iterate to make sure it keeps working. So again, that same idea of, yeah, there's a science that's very potentially valuable, but then you have to get across the valley of potential to real solutions that take advantage of the potential, but then also need to iterate, and you need to keep checking to see, is this really working the way we intended, and so forth. And so there's many of these disciplines and approaches around in other areas. Curiously, our education and training ecosystems at all level, from kids stuff to high school to higher ed to workplace, all of that, it's really not that evidence grounded yet. I think, I'll give you an example of this, that, the pandemic has been just terrible for everybody in many ways. And yet you see some things also emerging from it. So if you look at the healthcare pandemic, one of the interesting things is in spite of the disaster from a health standpoint, the evidence-based guardrails held, but the basic guardrails of the evidence-based model of disease and viruses and the immune system and all that has held. And wow, what an amazing progress was made against this vaccine and against this virus in a very short period of time by staying inside those guardrails, But now if you look at the education pandemic, right? The NAEP results just came out, and people could tell from the beginning, it was a disaster. There were no evidence-based guardrails, Bob. So people did the best they could. Everyone was kicked off the cliff into virtual learning, 100% virtual learning. Families didn't have machines and computers. Teachers didn't know what to do or how to cross-connect and motivate, et cetera. And there were no evidence-based guardrails to guide anybody at this. And you can see how terrible the solutions ended up being compared with what could have happened if people actually use some of the evidence-based principles that actually now have some pretty good evidence from, people like Richard Mayer and a bunch of motivation work from Richard Clark and so forth. So, sorry, long answer to a short question, that there really is a very important middle ground in the whole education ecosystem that needs to start getting filled. There are now, if you look, there are now more job postings for learning engineers, which is one way to describe that middle zone, just like a chemical engineer draws on chemistry but works practically, so learning engineer. There's even a couple of programs, schools that have grown up that are learning engineering programs. There's one up at Carnegie Mellon called the METALS program, Masters in Education, Technology, and Learning Science, set up by Ken Kadinger and colleagues up there. And it's a learning engineering program, basically. There's a learning engineering master's degree at Boston College. I think Stanford has a couple of programs that they would probably argue are learning engineering programs. It's still not enough. I mean, compared to 30,000 chemical engineers, we don't have that many people who actually have kind of a deep training in how learning and motivation really seem to work empirically, and are then working practically to iterate better solutions in the field. But I feel like we're beginning to see that that's starting to be an important thing, and people are beginning to realize that's valuable. The other reason for that is, I think, because the use of technology in education is increasing. And of course, the pandemic just, kicked that off the cliff to make it really be happening all over the place. And that means lots of companies and organizations and researchers now have access to lots of data about what is happening in detail between learners, their edtech environments, their teachers. And that data is easy. I mean, it's easy to get. It's not easy to understand. But compared to trying to get rich minute by minute, hour by hour data from classrooms, the classical classroom setting, that was really hard to do. But now, at least for technology mediated interactions, we've got a lot of data, and people are recognizing we should do something with this. Surely there's got to be some way to understand what's working for whom when. And I think that opportunity is then beginning to create pressure and reasons for people to say, well, okay, how do we understand this? How do we figure out what's going on and for whom these things are working well or badly? So for all those reasons, there is a very important, call it knowledge broker role, call it learning engineer role, call it translational research role in that middle zone that can really help, I think, make outcomes improve, both for motivation purposes, but also just for the actual design and learning environments themselves.
So let's go. You mentioned the pandemic, and so let's look for just a moment about what happened globally. We had, I believe it was 190 nations, at some point 1.5 billion students out of school, everyone out at least for some period of time, in a relatively short period of time. And so in terms of gathering the data, gathering information, and creating learning engineering, knowledge brokering capacity, what does that do for us? How does that provide us more of an opportunity to be furthering this? The globe, to my knowledge in education, at least, this may be the one universal epic event that has affected almost every school system and child in the world.
Yeah, and I think, again, by analogy, it's useful. So, the same underpinning biological sciences for malaria, for example, is now pretty much understood worldwide in terms of what causes malaria and the vectors through the mosquitoes, and underpinning mechanics, even genetics of what's going on. A lot of that is now agreed on, and so that's right. What's interesting is the solutions that make sense in a setting can look really different, even while the underlying reasons, the science, is the same. So, for example, it may be that in sub-Saharan Africa, for example, the best practical solution to start working on malaria problems are medicated nets, mosquito nets, and that solves a major problem in that specific context and environment, consistent with the underlying science, but also consistent with the constraints of those environments and those places. However, in, I don't know, uptown Manhattan or something, you have a very different set of affordances and constraints. And so the underlying science may get you to very different solutions and approaches. And so if you parachuted in from Mars, you would say, this is really weird. There's kind of furniture-based medicine in sub-Saharan Africa and pharmaceutical-based medicine in Manhattan. Wow, that is just really odd. Whereas in fact, both of them are evidence-based, but the context and the constraints have meant the best solutions can be very different from one place to another. And so I would argue something similar can happen in the educational world as well, that you have environments in some parts of the world where you don't have the kind of resource per kid dollar amounts and so forth that you might have in some of the Western European or United States contexts. But if you have an understanding of the underlying machinery of how practice and learning really matters, and what are the outcomes you actually want kids to be able to decide and do, and something about motivation, about how do you design for motivation for kids, not just for cognition, that then even if your solutions and the technology, if you will, those solutions might look very different from between rural India compared to downtown San Francisco, you're still building in a better way. You're increasing your odds of success because you're making use of what we know about human learning, about how our biological systems actually learn, and then you iterate. And that's the other part of engineering. I mentioned it earlier in the chemical engineering context is, you want to get the best first draft out there you can, but you also want to have a certain humility that you celebrate success, but you instrument for failure, right? You kind of are expecting that you're going to have to do this again. And the trick is to know, well, which parts are not working so that I have a clue of what to fix, as opposed to saying it didn't work and then just having no idea what I'm supposed to fix. So that notion of iteration, grounded in evidence, both evidence from current implementation, but also evidence about how learning and motivation actually work, all of that increases the odds that our iterations will actually make a difference. And I think that notion of context being so important is something that is easy to miss. I mean, we'd all love the little silver bullet, right? We'd all love one curriculum to rule them all, right? One method, one ed tech platform that could work everywhere equally well. And yet, that has not happened yet. It's incredibly unlikely to happen. And I actually feel like, and I can't remember, Bob, if you and I have talked about this, I think the mistake, even in education reform over the last many decades, but especially now with ed tech, I think in some ways we're thinking too much as if it should be like software engineering. We just make one great product and then get it everywhere, and that will be the way we add value, when there are other engineering traditions that are really different. So the engineering tradition that I think about a lot these days is civil engineering. So if you're going to go build a bridge across the Potomac, you do not copy and paste a bridge from the Hudson. You go to the Potomac and you visit and you look and you check the soil conditions and you ask about weather and you investigate the usage, and not just on the day you visit. You're asking what's going to happen 30 years from now, 50 years from now. So you have all kinds of context information that's going to matter. And then you have evidence-based principles that you use to design the bridge for this context. In addition, you don't have to design every piece of it from scratch. You don't need a new steel forge, but you do know what are the performance characteristics of the parts and pieces you need. And so you can assemble most of it from catalogs, knowing what the constraints are and applying, your principles of how to do an evidence-based design of a bridge. And yes, you want to instrument to make sure that you can check, is this working the way we intended it once we actually put it into place? And so I think that mindset is where we're really going to need to take the whole ecosystem, is much more of a context first mindset, as opposed to, I do have a square peg, so let me, get this jammed in here somehow. There's Chris Deedy at Harvard Graduate School of Education. He's talking about, and some colleagues of his are talking about, component-based research as being research about learning interventions that is, highly rigorous and careful and publishable and all that, but pays a lot more attention to who are we testing this on? What are the characteristics of the learners, the teachers, and the schools, as well as being narrower in terms of what are the outcomes that this component is trying to achieve. So instead of testing a whole year math curriculum, you look at a key misconception part, and then you test that and you track very carefully what are the kinds of students that we've got, so that your evidence is about how does this component work for these kinds of students. And I think that's a key part of how this has got to work going forward.
So how does an organization like the Global Science of Learning Education Network, GSOLEN, which is many hundreds of researchers across and educators across the globe, many different situations, what role do you see for GSOLEN in furthering these concepts?
So I could imagine a few. One is, again, if you think about other areas of engineering, if you will, or knowledge brokering, if you will, there does end up being some common principles and approaches that underpin everyone who's engaged in that work. So even whether you're a psychiatrist or a neurosurgeon, I mean, these are very different kinds of physicians, right? They've actually all been exposed to a somewhat similar set of stories about human health, human normal functioning, anatomy, things that go wrong, nature of pharmaceuticals, processes for creating new medical interventions and so forth. And then, of course, they each go really deep into their own areas and know a ton about that. But when they get together, they actually share a kind of a, call it a story of medicine, of biology, of treatment, that allows them to quite rapidly talk to each other and then go into the depths they need to. And I would argue that we don't really have that kind of a common evidence-grounded set of principles or stories across educators, ed tech developers, education researchers, and so forth. So organizations that are bringing together, a wide array of people with different backgrounds and different foci and so forth, there's an interesting opportunity to try to figure out what does GSOLEN pull together as the story of human learning and motivation? What is there something like that? Now, it'll probably take a decade to do it or whatever, right? But when you look at other efforts to come up with common language and stories, yeah, it takes a long time, but you end up with some real benefits as a result. So that's one of the pieces. I think another piece could be, and again, this all may be too hard to do in the near term, but even something as specific as deciding on common ways to describe context. And I think, wow, wouldn't it be amazing if we could figure out, well, what are measures that we would agree are good measures of important outcomes, both motivational as well as, inside the academic side, and even descriptors of context. how do we want to describe the context in which learning is taking place? And I think of Bart Epstein's work at the EdTech Evidence Exchange as an example of trying to come up with and then validate sets of descriptors of learning contexts as predictors of where EdTech might work or might not work. Those are the kinds of things that over time can then help people more quickly see as they talk to each other, what are you working on? Oh, okay, I get it, I understand that, as opposed to spending a lot of time on, I don't even understand the category of learning you're in, or I don't even understand the way you describe those students. That doesn't match how we describe our students at all. So there's aspects of that that's almost a standardization thing that eventually might come in. There could also be an interesting role for G. Solon to talk with some other organizations that are beginning to think, hey, maybe there is this learning engineering stuff, like Digital Promise. You may have already talked with them. They are trying to do some work with EdTech companies and others on what is underpinning learning science. How can we communicate that to the developer groups? So again, wouldn't it be cool to have G. Solon and Digital Promise, begin to work together to see how do we describe this? Icicle, which is an outgrowth of the Institute of Electrical and Electronic Engineers, IEEE. It's an effort by IEEE to create a profession of learning engineers, basically. And Icicle mostly right now is tied to corporate learning, adult learning, things like that, but absolutely has wings of work connected to K-12. And again, you could imagine, they're the folks who just released this really great book called The Learning Engineering Toolkit. If you haven't seen it, just came out this summer. It's a very nice multi-dimensional view of what it is to do learning engineering, including a chapter on ethics, a chapter on learning analytics, a chapter on engineering processes, yes, a chapter on cognitive science and so forth. Well, so again, having Icicle and some of the folks who are the thought leaders there cross-connect with thought leaders inside G. Solon, but again, that notion of what should we be thinking together, and how should we begin maybe assembling a story of learning and mastery and motivation that more people can then start to sign on as a down payment towards then getting much more specific into the individual areas. I don't know if this helps, Bob, but that's kind of what I've been thinking.
No, it helps a lot. The final question is, so you had mentioned degrees and institutions that give degrees in learning engineering. If the goal is to move research and science from the lab to the classroom, to where it's applied in an effective and efficient way with improvement in student outcomes, is this a profession that needs to be developed, or is it a set of skills, general skills that can be that people can learn in their respective work, whether they're educators, whether they're researchers, whether there's somehow in the middle policymakers that are in the middle, district superintendents? So does it need to be a profession, or can these be skills that can be developed in people already doing in their line of work?
I definitely think the latter is correct, that this is definitely information, learning approaches that absolutely can and should be acquired by people who are at the front lines trying to make decisions right now. And again, just like in any profession, there's various levels of depth that you may want to get to based on what you're actually making decisions about. And so the trick there is, well, so where would people go if you're a superintendent or a teacher and you're trying to understand, how do I improve my odds of success with my decisions about my learners based on knowing more about the evidence about learning and motivation and so forth. And so could that be a sequence of online experiences and courses? I would say yes, it certainly could be. I mean, is that a role for G. Solon or others to build, whether they're certification programs or they're just simply
micro-credentials or
exactly. And guess what? Design those as if learning mattered. Actually use learning engineering to design those so that those experiences become tangible examples of the kind of practice and feedback that's really needed to change human minds. And there's also like creating indices and pointers to, trying to think how to put this, well-digested learning science, right? Because, hand somebody 1,000 pages of research reprints, you're not doing the work. I mean, that's not helpful to anybody. But there are some of these volumes like that learning engineering toolkit, like the part from Rich Mayer and Ruth Clark, e-learning in the science of instruction. These are explicitly intended to synthesize from the increasing amount of science of learning work to principles that can be applied by instructional designers, learning engineers, teachers, other decision makers in their own fields. So, trying to figure out, well, where do we make it easy to find information you would need to build your skills? That could be in many different places, but is absolutely needed. I do think over time, schools and education are such natural places to build teachers as learning engineers, very practically oriented towards the students in front of them. As the kids get older, even inside a domain like math or biology or English, whatever it is, but they should be problem solving and thinking with learning engineering principles, learning evidence-based principles around motivation, as well as the domain learning. That should be what they are practicing along the way to becoming the teachers that they are, so that when they then pick up the curriculum from whatever school they go to, they actually have a lens on that curriculum and their students and can see what are the gaps between what I'm going to have to do and what I know about human motivation and these kids, what I know about the gaps my kids have, and that I also have personal assurance from the evidence that all these kids can achieve mastery with the right practice and feedback, brought in with them, and that I can communicate to them, no, you can achieve your dreams with the right practice and feedback tied to the things that you love and know, and then helping to figure out what you don't have yet and making that all work. And I would say that's one of the things to me, Bob, that's so heartening about evidence-based approaches. People think evidence-based, oh my God, it sounds so cold. It sounds so, scientific. And it's, where's the warmth? Where's the emotion? And what I would say is, when you start to read and understand what learning science says about the potential for humans to change and learn, it's incredibly optimistic around how we can alter what we think, what we're engaged in through practice and feedback headed towards the right things. And so many more of our kids can actually, achieve success if we allow ourselves to engineer their experiences to match up with their own interests to begin with, and then towards new interests that they develop as they begin to learn. So to me, that notion of bringing together, the researchers, and then creating vehicles for practitioners, for principals, for investors, for buyers, to increase their odds of success through the right kinds of use of learning science principles. I think that is not just possible, but necessary in order for us to make the changes here over the next set of years.
You and I were at a function Saturday night in which one of the founders of LinkedIn was there. And as I was there, I was thinking, how do we link our researchers, our scientists, our educators in a practical way? And in the research I've done, yes, there are platforms, or there are efforts made by different research institutions to link researchers with fellow researchers and share dissertations and so on. But here is where the rubber meets the road, as researcher to classroom teacher to practitioner. Any suggestions on, are there existing platforms, existing technology, as opposed to inventing something new, that could accomplish that, or that could be adapted to it?
So I think there are several, and there's more than what I know of, but there are several efforts and organizations that I think are already doing that kind of work and trying to make it work. So for example, I think about Transcend Learning.
Yes.
Elon Samoa, Jeff Wetzler, the founders there, and their work over now several hundred schools to bring the science of learning and motivation directly to students, parents, and teachers to help redesign schools. And they have now, they have outreach to researchers and people with various kinds of tools and capacities and measures, trying to stitch these things together, as well as trying to now build evidence bases. I think they're an interesting example of how to do it. Another place that I think is making progress is the League of Innovative Schools, that's kind of overseen by Digital Promise. They are now, I think, trying to advance from being a useful kind of sharing of practices kind of environment with 4 million kids, and it's a huge number of schools. They really are now beginning to talk about, okay, how do we create what we talked about earlier, some common underpinnings of measures or context or otherwise, so that we can look amongst each other to say, who can I really learn from? Not just listen to your story, but who's like me? And then what have you done that's successful for your kids? Because then I should be trying that myself and seeing how this works. So I think the League of Innovative Schools is another kind of organization that's trying to pull some things together. And then there's other, I think, groups, networks. Lean Lab is another one. It's been based in Kansas City. Katie Booty and her team, but they are pulling together. They've been doing this for several years now. They pull together EdTech developers with the school communities there to solve what the schools say are their hard problems, and they support them to really co-create and co-design, and then see if they can make that work and turn that into scale. It's another example of bringing together these folks who often don't get a chance to see each other, but really pull them together. And the fourth one, I know this is more than you wanted, but the fourth one I'm thinking of is AirDiff, the Advanced Education Research and Development Fund. Yeah, that's what it stands for, which is a jointly funded by a number of philanthropies. They are working very hard on inclusive design, where they are, from the beginning, bringing in teachers and students from the targeted schools and contexts to actually even evaluate the researchers who are going to be involved, so that from the very beginning, that question of, will this work in the communities that we want it to work in, is being addressed. It's not like an afterthought. It doesn't come late in the game. It comes way early in the process. And so they're making progress on several initiatives. The furthest along is one involving math and executive function, I think. They have a couple of other new ones that are happening. But their work along these lines, I think, is just really valuable as well. Getting these folks to begin to be exposed to each other, to talk to each other, to discuss, how do researchers get engaged, and how do we get the most out of this? And what you'll find, and this is true in all these different ecosystems, medicine, chemistry, and so forth, you'll find some researchers who just honestly just love their lab bench. They honestly, it's just too messy to get involved with the real world. There will be others who may be very interested in how do we make practical use and want to cross over. And then there will be some who will start on the research end of things and then may decide, hey, you know what, I actually want to full on go into this learning engineering work. And they don't even know right now what that means or how to do it, right? And so by creating some forums and conversations to start to show what is possible, then you can start to create people who transition around. And that is beneficial all the way around, because you still get movement of ideas and problems back all the way up into the research pipeline from the front lines, because you have some common language going on between all those folks. So I would argue there's more there that could be explored.
Great. Anything else to add? This has been incredibly helpful.
Well, I think, G Solon is such an interesting organization, and, really look forward to seeing, how can that group of global folks engage and bring together people, across the globe to, benefit every learner in every place, because things you will learn in one part will be beneficial in other parts. And some things will be very easy to check in one place and much harder to check in another place. And yet it is all about human minds, human emotions, human motivation. And there's a lot of common underpinnings about how we're put together. And so great to see what we can do.
Great. And thank you, Bror. Thank you for all your help.
You are very welcome. You are very welcome.